Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 2 of the February daily Leetcode challenge, and this is the second day that we are having a easy question. On the day 1 also we had easy question, and this is the day number 2. Okay, now this question has been marked easy, but many of the peoples are commenting that this is not easy question. This is slightly on the harder side, or they can say like this on the medium side. Okay, so you will have to tell me whether this is easy or medium level question after I show you my solution. And by the way, as I am showing you, like my solution is beating 100% of the other solutions that people have submitted. Okay, I just want to show the start itself so that you don't have any doubts like in what you are learning. Okay, this is the question. So our always the target should be to beat 100% of the solutions, and that is what my solution is doing. Okay, so yep, just wanted to show this before I start. Now coming to this question, it's 1752. Check if array is sorted or rotated. Okay, sorted and rotated. So let me zoom in. Let us begin. Yep. As you can see in the input, we are just given integer array, and if you see the length, okay, because it's an easy question, I'm sure that you would have already predicted what are the constraints going to be. C. So the length is going to be till 100. It is between 1 and 100, and the values are between 1 and 102. Okay, this doesn't matter. This one is not that important to us, but yeah, this thing is important. You can even try with brute force. That is what they are trying to tell you through this. Okay, now let's see the question. Given an integer array, given array nums, return true if array was originally sorted in non-decreasing order, then rotated some number of positions. Okay, fine. First of all, we'll decode this whole thing. We'll go one time by one time. Okay, now first of all, what is the meaning of this? What is non-decreasing? Okay, see, if you see the input, something like this. Okay, that is, it is increasing order, but why they mention non-decreasing? Non-decreasing means that two adjacent values can be same. Okay, that is what is the meaning of non-decreasing. Okay, two adjacent values can be same. Otherwise, adjacent values have to be in such a way that they are increasing. Okay, for example, see here, see 1 and then 2. Okay, so what happened after 1, the next number got increased by 1. Okay, now this number could have also been 1. Okay, so that's the difference between increasing and non-decreasing. Okay, non-decreasing means that adjacent elements can be same. Okay, as simple as that. And also in the other case they can be increasing. Okay, it has two parts. Okay, first part is it can also contain strictly increasing elements. Okay, well, that's point number 1. Second point is that it can also contain elements which are same. Okay, as simple as that. That is the meaning of non-decreasing. So now what they're trying to tell you, return true if the array was originally sorted in the non-decreasing order, then rotated some number of positions, including 0, otherwise return false. So what they're trying to tell you that, see, let us say this was the original array. Okay, now what happened, see this 1 and 2. Okay, actually what happened, this whole array will left shifted by 2 times. Okay, what happens with left shift, this particular 1 will now come here. Okay, okay, one thing I will do is I will write it and show it to you. That will be making it more clear. Okay, now see this part. So see, this was the original array, right? As they mentioned, the original array is always sorted, okay, in this particular order, okay? That is the non-decreasing order, right? Now, after left shifting it by one time, what will happen? See, it's very simple. After you left shift by one time, this is what it is going to look like, okay? You can like copy rest of the elements here, okay? Let me zoom in. Yep. Yeah, you can just copy rest of the elements here, and then one will come to the right. Okay, so what happened, this particular one came to the right. Okay, that is the only difference after doing left shift by one. Okay, if you do the second left shift after happen, say exactly same thing, just copy all the elements and only the last element will left shift. Okay, see this part. Okay, just a second. Yeah, after one, two will now come. Okay, so this is the result after two left shifts. Okay, so this is what we are given basically. Okay, 3 5 3 4 5 1 and 2. Okay, 3 4 5 1 and 2. So as we know, this is achieved by left shifting the original sorted array by 2 times. Okay, as simple as that. So we can say that yeah, the answer for this is going to be true. Okay, when we have to return true, we have to return true if the array was originally sorted. Okay, as simple as that. And we did some shifting by some of the positions. Okay, remember the left shifting could be even done for 0 times. That is, it's 0 or some non-zero number. Okay, as simple as that. Return true otherwise. Okay, return false otherwise. There may be duplicates in the original array. That's say, and there are duplicates. That's what is the meaning, right? That is what is the meaning of non-decreasing order, right? Yep. Now, note an array A rotated by X position results in an array B of the same length such that A of I is equal to, okay, they are just trying to tell you how the, shifting operation works, okay, as simple as that. So how the rotation works, that's what they're trying to tell you. But again, with the example, it's very much clear how what is happening, okay. This was the original array. After doing a left shift by 1, this is what it is going to look like. After doing a left shift by 2, this is what it is going to look like, okay, as simple as that. Now, how to solve this question, okay. You can go through other examples. In this case, if you see there is no left shift, the original array itself, the input given itself is a sorted one. Okay, so the answer is obviously going to be true. In this case, if you see, it is false. Why it is false, we'll come to that. But how to find a logic for this now? If you analyze this part very carefully, you will notice one thing, that it is behaving like a mountain. What is a mountain? See, mountain means that it will go till the top. Okay, there is a top. For example, from 3 to 4 we are increasing, from 4 to 5 we are increasing. Okay, here 5 is the peak. What is the peak? Peak means the highest point in the mountain, right? So 3 is the bottom of the mountain. From 3 we're increasing, and finally we're at 5. Okay, 5 is the peak. After the peak there is a decline. Okay, after 5 we are coming to 1 and then to 2. Okay, this is just like behaving like a mountain. But how to ensure that it follows the increasing? Okay, how to ensure that the original array was sorted? How to do that? See, it's very, very simple. Okay, let me write it here. See, I will have two values. Okay, first I will declare a min element. Okay, what is the min? Min will be, okay, so for now this is the input, right? Okay, just a second. Yeah, this is the input. Let me have it just this. Okay, so always the first element. Okay, let me zoom in. So please pay attention. This is very simple. If you just understand this part, now the whole concept will be clear. See, I am taking the first element as the min. Okay, now after this there will be a expansion phase. Okay, there is a phase where the elements are increasing. Okay, so we will go till the peak. Okay, now 5 is the peak. Okay, after 5 what will happen? There will be decline. Now, so how to see the decline? See, idea here is after 5, okay, 5, see, 3 to 5 there is expansion. Similarly, from 1 to 2 there should be expansion. Okay, now 1 is there. After that the next element should be 2. Okay, the 2 can be either greater than or equal to 1, fine. But remember, all the elements after the peak, okay, since 5 is the peak, all the elements after the peak should be less than the first element here, okay, which is the min element. Do you get me what I'm saying? See what happened. It was like this. Okay, 1 2, then 3, then 4, and then 5. Right now, since 1 and 2 were left of 3, are you getting what I'm saying? 1 and 2 were left of 3. Do you get it? Since they are left of 3, and then we somehow, we shifted and rotated, and they, came here. They came now after the peaks. They came after the last element. So what should happen is, once you reach the peak, okay, you will get to know that, okay, the next element is not following. Okay, so what you will do? See, if you do 4 minus 3, you are getting a positive number. Okay, either positive or, 0. Okay, when you do 5 minus 4, you are getting either a positive number or a 0. Similarly, if you do 1 minus 5, you are getting a negative number. So when you get a negative number by subtracting two actual elements, you are sure that, okay, we have reached the peak now. Okay, and now these elements starting from here is something we have to check for. Okay, now all these elements to the right of the peak has to be less than this particular element. Okay, all the elements to the right of the peak has to be less than this element, and they also have to follow the expansion property. That is same thing like as we saw here. 2 has to be either greater than or equal to 1. Okay, same thing like that. Okay, to follow this property, okay, there is a non-decreasing property, right? We saw non-decreasing order. Same thing it has to follow. So 2 has to be less than or equal to 1. Okay, similarly, 1 and 2 and all the elements, by the way, toward the peak, up to the right of the peak, has to be less than or equal to 3. Okay, that is the min element. So that is something that we are going to follow now. Okay, now how to do that? So before that, let me take you to example number 2. Okay, see here. In example number 2, what is happening? See, from 2 we went to 1. Okay, that means 2 is supposed to be the peak. Okay, see, from 2 we are basically falling down. So 2 is supposed to be the peak. Okay, that is all the elements now, okay, towards the right of this should be less than or equal to 2, ideally, right? Ideally. But what we are seeing, there is a number 3. So 2 is supposed to be the peak. After that, how we are having an element which is greater than 2? So for that reason, the answer is not possible here. So we have written false. Okay, this was not sorted at all. So even if you do multiple shifts, you will not be able to get array which is sorted. Okay, as simple as that. Okay, we will not be able to get a sorted array back. Okay, yep. So now how to solve this question? See here. What I'm doing, I'm first of all capturing the length. Then, as I mentioned, the zeroth element of the given input is going to be the min. Okay, now we are declaring a variable called peak reached. Okay, it is false initially. Okay, when we reach a peak, then we will be making it true. Okay, now I equal to 1. We'll start from I equal to 1. Okay, so till I is less than equal to 1, this will follow. Okay, so till I is minus 1, so it basically will go from 1 to n minus 1. Right now, if nums of I minus nums of I minus 1. Okay, if it is greater than equal to 0, then we are fine. Just increment I and continue. That is, go to the next iteration. Okay, so what is the condition? Nums of I minus nums of I minus 1. Okay, so if it is greater than equal to 0, then we can say that, okay, it is following the non-decreasing order, so we can proceed to the next iteration. Let us say it fails. Let us say a case fails. So what will happen? So when it will fail, see this part, it will fail in this particular step. Okay, when we do 1 minus 5, in that case it will fail, because 1 minus 5 will give a negative number. A negative number is not greater than equal to 0, so that it will fail. So what we'll do, we'll do this part, p set equal to 2, and then we are breaking out. Okay, so this particular value will be breaked, and we are turning this variable on. Okay, now once we come out of this value, what we are checking, we are just checking if the peak reached is 2. Okay, if it is 2, then what will check, whether the current I, okay, whether the current value of I, that is the number, that is the value in which is present in the index I, if that is greater than min or not. Okay, that is, I'm checking for 1 now. Okay, I'm just checking for 1 now, if 1 is greater than 3 or not. Okay, if 1 is greater than 3, we have written false, because remember, all the elements towards the right of the peak has to be less than the first element of the input. Okay, as simple as that. So if it is greater than, okay, peak, we'll have to return false. Remember, it can be equal or it can be less than peak. Okay, so for example, 3 is here, right? So this particular one can be either 3 or this can be even less than 3. Okay, as simple as that. But it cannot be greater than 3. Okay, for that reason, if it is greater than 3, we are returning false. Now we're just doing I plus 1. So let us say I 1 and 1 now. I'm now going to 2. Okay, once I am 2, I will follow the same thing what we did here. We'll just exactly do the same part. Okay, same thing we are going to do now. See, while I is less than n, okay, what we have to do, same thing. Same, this particular what we saw, same thing we have to repeat here. If nums of I is greater than min, then we have to return false. Or if nums of I minus nums of I minus 1 is less than 0. Okay, so if it is less than 0, that is it is not following the non-decreasing order. Okay, in that case also we'll have to return false. So what are the two conditions? This is the first condition which we already saw. Okay, now every number after the peak has to follow this property, that it has to be less than or equal to 0th element. Okay, 0th element. So that I'm checking first, then I'm checking this part. Okay, that is a non-decreasing order. Okay, non-decreasing property. Now, if nums of I minus nums of I minus 1, if it is less than 0, then it is not following the non-decreasing property. In that case, again, we have to return false. Okay, if that's not the case, what we have to do, simply increment I plus 1 and go to the next loop. Okay, this will keep continuing. And let us say we come out of this loop, without any return statements, then finally we return true. Okay, so yeah, and that was all the solution. Let me quickly run this and show it to you. As you can see, this is clearing all the test cases, and I've already shown you this was beating 100% of the test cases. If you talk about the space and time concept of the solution, yep, as you can see, we are just going through each element only once. Okay, we are going through each element only once, so it is a O of n solution in terms of time complexity. And as you can see, we are not using any space. Okay, we are just using some variables. Okay, we are just using some variables. Okay, we are using two variables by the way, and n is also there. Okay, so total three variables. And if you consider I also, then four variables, right? But again, these are all constant. These are not dependent on n. Okay, for that reason, space complexity wise, it is going to be O of constant solution, O of one solution. Time complexity wise, it is O of n solution. So yeah, that was all for this video. The topic is very simple. You have to find a peak. Once you find a peak, all the elements to the right of the peak have to be less than the first element of the input. Okay, that is point number one. Second point is that all the elements to the right of the peak have to follow non-decreasing order. Okay, as simple as that. Okay, same thing. Okay, all the elements till the peak have to follow non-decreasing order. Similarly, all the elements after the peak also have to follow non-decreasing order. But extra condition is that all the elements towards the right of the peak have to be less than or equal to the first element of the input. Okay, yep. Why it is so? Because if you like, just imagine this is sorted one, right? In the sorter, what happened? 1 and 2 were before 3, right? Similarly, now 1 and 2 should be before 3. For that reason, 1 and 2 should be less than or equal to the first element of the input. Okay, that is all what we have to check. And yeah, and that was all for this video. This was an easy question, but yep, as I mentioned, many people commented that they felt it a bit difficult to solve. They felt it was a medium level question. But yeah, it's up to you. Like, let me know your thoughts in the comment section what you felt. But yeah, this is what my solution is. And as you can see, this is clearing 100% of the test cases and it's beating 100% of the solutions. So yeah, that was all for today. If you like my efforts, if you like the way I'm teaching, or if you are getting at least something extra to learn, please do subscribe to the channel. This really gives a lot of motivation to continue further. Our aim is to create quality content even for the people who are not able to afford some fancy courses, because in today's world everyone is trying to sell the courses. No one is providing quality content free. My aim is that I am improving myself in coding. At the same time, I want to make some quality content available for people for free, so that with a single internet connection they can get some of the quality sources. So yeah, that was all for today. If you like my efforts, if you want to be part of this community, please subscribe. This really gives us a lot of motivation to continue further. See you tomorrow. Thanks a lot.